In the early 19th century, the map of our solar system stopped at the seventh planet, Uranus. But when astronomers tracked its orbit, they found a persistent glitch. Uranus was accelerating and decelerating at the wrong times, seemingly breaking Isaac Newton's established laws of gravity. French astronomer Urbain Le Verrier decided Newton's math wasn't wrong, it was just incomplete. Working entirely with pen and paper, Le Verrier calculated the mass and gravitational pull of an invisible ghost object hiding out in the darkness, quietly tugging on Uranus. He sent his mathematical coordinates to an observatory in Berlin. When they pointed their lenses at that exact spot in the sky, they confirmed Neptune's existence. It remains the only planet in our system located through the precision of mathematical prediction before it was ever seen through a lens. The discovery was a long time coming. Galileo had actually recorded seeing Neptune in his journals centuries earlier, but his primitive, slender telescopes lacked the power to resolve the planet, causing him to log the gas giant as a distant, static star. This breakthrough proved that the far edges of our solar system hide massive, violent anomalies that operate well outside the reach of human senses. Crossing the 5 billion kilometers of empty space between Earth and Neptune takes a spacecraft 12 long years of continuous travel. That massive distance creates an incredibly slow journey around the Sun. A single orbit takes 165 Earth years, locking Neptune into brutal, unchanging seasons that last for 41 years at a time. Even at high noon on a clear day, the sunlight reaching the cloud tops is terribly weak. The brightest part of Neptune's day looks almost exactly like the dim, fading twilight on Earth just after the sun has dipped below the horizon. Orbiting through this dark twilight is Neptune's largest moon, Triton. It travels in a retrograde orbit, moving in the exact opposite direction of the planet's rotation, a scarred piece of frozen rock caught in the planet's gravity well. Triton's surface maintains a temperature of nearly 400 degrees below 0 Fahrenheit. At these extremes, active cryovolcanoes spray geysers of frozen nitrogen and ice particles straight into the black sky. Neptune's orbit functions as a high-speed, sub-zero environment, where even volcanic activity is driven by ice rather than heat. The planet's color is a product of atmospheric methane. These molecules absorb incoming red light from the sun and reflect the blue light back out into space, creating the visual illusion of a deep blue ocean. Dropping beneath the clouds reveals a lethal atmosphere, with constant winds exceeding 2,000 kilometers per hour. This chart puts that force into perspective. Earth's most destructive hurricanes barely register against the towering threshold of a Neptunian gale. These extreme winds are driven by massive storm systems, like the Great Dark Spot. In this image, you can clearly trace the dense white clouds being dragged around a deep blue planetary-scale vortex. The physical scale of this single storm is difficult to comprehend. The entire planet Earth could easily fit inside that churning gap in the clouds. This is why Neptune remains a non-landing zone. There is zero solid ground to touch down on, only a violently churning atmospheric meat grinder. Falling beneath the gas layer takes you into a slushy ocean of water, ammonia, and ice that stretches down for 17,500 kilometers. This diagram compares our oceans to Neptune's mantle. Earth's deepest point, the Mariana Trench in the Pacific, is a tiny speck next to the sheer, inescapable crush of this 17,000-kilometer descent. As you sink deeper, the atmospheric pressure becomes so intense that it actively squeezes loose carbon atoms into solid diamonds that sink through the abyss. At the very bottom of this fluid crush is the planetary core. Despite floating billions of kilometers away from the sun, the temperature here reaches 5,100 degrees Celsius, nearly matching the heat of the sun's surface. This results in a world that maintains a sun-hot core while remaining entombed in a massive, lightless layer of high-pressure slush and ice. Pulling back from that core reveals one surprisingly familiar trait. Because of how its mass is distributed, Neptune's gravitational pull is nearly identical to Earth's. A person weighing 100 pounds at home would weigh about 114 pounds in Neptune's upper clouds. Yet humanity has only briefly brushed past this world. When NASA's Voyager 2 flew by in 1989, it became the first and only piece of human technology to reach this distant giant. Decades later, the planet remains entirely unprobed beneath its upper atmosphere. It stands as a dark, violent frontier, a distant blue giant that continues to challenge our understanding of planetary physics.